Hello there everyone, it's Malcolm Budden here from MNB Networks. In this short video I'm going to ask you some thought-provoking questions in relation to network design. One of my observations in the last little while is that it's easy to jump to conclusions as to what we should be doing even when we don't understand the full picture, and that's not to just say full picture as in what the existing network looks like and what the customer wants to do, but sometimes the customer might not know what they want us to do or what they want to do, and it's our job as a network designer to work that out. So I'm going to give a few examples of that have happened recently, and hopefully it'll be an interesting video for you. Okay, so let's talk about a requirement where there was a customer who had two core switches like this, and we're on the phone call with the customer. MNB Networks has a bit more fancy phones than this, but we've got soft phones. But the customer is telling us, MNB, that these two core switches are linked together and they have downstream switch stacks which are connected like this. These switches are clustered together either as a stack or a VPC or whatever, but regardless, these are a port channel. Okay. Now, the challenge that we've got are that these switches pictured in the diagram are end of support, end of life, or they're coming up to that point. So if I was to ask you, and you were the customer, how do these things currently operate? What would you tell me? What would you volunteer in respect to information? You probably say it was I don't know, a Cisco or an Arista or Juniper or a HP or an Aruba or a Fortinet, maybe a Fortinet core switch, and you don't care what it is in the future, you just want these to be nice, shiny, new switches that connect to the existing core, the existing access layer. The access layer being these switches here. So in your mind as a network designer, you've got to really think about a stage or the stages as to what you want to ask. What do you want to ask about here? You need to know some information about layer 1. You need to know some information about layer 2. You need to know some information about layer 3. And the best way to achieve that goal is to get show outputs. So that might be a show run. It might be a show IP interface brief. Maybe show VLAN. And then that could have multiple different subcommands and all that kind of thing. Once you actually understand what is running on that switch, and in this particular scenario, you might be told that it's a very simple switch configuration, and you've got two cores that connect to the rest of the network as shown in this diagram. Very simple. But the reality of it might be that you might have access layer stacks, and in this scenario you might have something like this, where why do you think I've drawn different coloured cables here? Well, let's just say that's 1 gig copper, and this is 10G fibre. And the reason for that is that in order to do this and this, and then make this a port channel, failed when someone tried to implement it. Okay, so if we go back a little bit, and rub this out, what would you do in this scenario? If a customer said just put it in exactly like it is at the moment, what would you do? Well, what I would do is say that's not an efficient way to connect it. Whatever these switches end up being, I'm going to connect you here like this and give you 20 gig 20 gig port channel and a 20 gig port channel. Okay, so there's so many reasons why this might have happened here, where you've got the 1 gig plus a 10 gig, but we're not going to go into that at the moment. I'm going to call this scenario number 1. All I'm really doing here is giving you some examples as to what network designers face and the types of challenges that we face each day. The next challenge I'm going to give you is challenge number 2. Let's revisit the core switch conversation and say we're going to replace 2 core switches. In fact, I'm going to make that a bit further apart, and I'll explain that why I'm going to do that in a second. Let's say we've got 2 core switches, and each of these core switches has to be copper. So if we've got copper ports in blue, now I know what size of switch I need to draw. So let's just say this is a 24 port switch. From a copper perspective, there's your 24 ports, and I'll probably need to rub this one out and draw an equivalent, which I'll do now. Strangest looking switches you've ever seen in your life, but they're switches. There you go, there's 24 copper ports. So the copper is 1/10G copper. So that's 1 or 10 gig. And then in addition to this, we might have 6 ports on the end, like that. When I say ports, I'll explain what I mean by this in a minute, but just going to challenge you, if you're watching this video, to say what kind of ports do you think these are? If these are data center switches, what do you think they are? Okay, let's just put you out your misery and tell you they're 40/100 gig QSFP 28 ports. Now, if you're not familiar with the different types of SFPs, let me give you a whistle-stop tour. SFP, you can look this up yourself, but it stands for small form factor pluggable. So anything with SFP, that's what it stands for. I'm not going to draw it out here or write it out here. But there's different flavours of SFP. So there's an SFP, which is typically 1 gigabit per second, and that can be fibre or copper. That is if you've got if this is a port on a switch, you put like a transceiver, you plug it in. So you plug this transceiver into this port, which equates to one of these. You've then got SFP plus, which is 10 gig, and that's fibre only, and it's single or multi-mode. Single mode or multi-mode. This could be single mode or multi-mode. If you don't know what single and multi-mode fibre is, then this video might be a bit too advanced for you, and you need to go and look at what single and multi-mode fibre is. But SFP Plus supports fibre only, and it also potentially supports an SFP Plus port. If it's the port that you're putting the transceiver is, it can also support an SFP, right? So it can support a 10 gig or a 1 gig transceiver. Typically, it depends on the vendor, really, but an SFP Plus port can sometimes support 10 gig or 1 gig, but it cannot support 10/100 meg. Anyway, this is getting into deep optics, right? So then we've got a QSFP, which is 40 gig. And the main difference is this is fibre, but it's a different hardware. So it's a different size. So if this was a QSFP port, it would be different transceiver or a different transceiver that plugs in. And then we've got QSFP 28, which is 100 gig, and it's fibre, where it can be backwards compatible with 40G, because these two are loosely grouped together, and these two types of connectors are loosely grouped together. Now, if you think about this in layman's terms, you can think about an SFP being that size and a QSFP being this size. What happens in an SFP is you have an SFP or an SFP plus having a transceiver or something plugged in, a module plugged in, and then a fiber cable being connected somehow either via a patch panel or directly if the switches are in the rack. Okay. With a QSFP, you would have a 40 gig, maybe put this in a different colour, a 40 gig transceiver or a 100 gig transceiver going to a 100 gig transceiver with a fiber cable. That's a QSFP. And they look the same size, but they are different transceivers. So you couldn't put a 40 gig transceiver in or module transceiver. I'm going to keep saying transceiver, and I'll show you a picture of what a transceiver is in a second. But you can put a QSFP transceiver in at 40 gig, but you could do it would need to be 40G here and 40G here. You cannot put 100G here and then connect them like that. That's incompatible. You would not be able to do that. So you would either need 100 here and 100 here, and then put the cable between them, like this one, this cable here, or it's a 40 here. I hope that makes sense. And it's the same thing where as if it's a SFP to SFP. Fine, all good. If it's a SFP plus to SFP plus, that's good, that's fine. But if it's an SFP plus to SFP, that doesn't work. That does not work. So another scenario, right, that all I'm trying to specify here is that the selection of the correct SFPs is critical. Now, we've not even got into talking about twinaxes. What are SFPs that I just explained to you there? How this is basically constructed is that you have a switch, okay, and then you have a port, and then you have an SFP, and then you have another switch, and then you have a port, and then you put an SFP in. But then there's different ways that we can actually connect these SFPs. We can connect them directly. So let's say they're in a rack, and this is the SFP or QSFP or whatever form factor it is. We can just go direct, or we might need to go via a patch panel. And let's say we've got another port here, and we connect the port on the switch to the patch panel. So the transceiver, if this is the transceiver that goes into the port, that connects into the patch panel, but then a separate structured cabling is then presented between patch panels. The other thing that, or consideration that we have, is when we understand what this, and this cable should be. Is it single mode or multi-mode fiber? And that's what we were talking about here. Single mode or multi-mode. another way that we can potentially connect these, because what I just explained there, if you look at how the port connects, if this is the port and this is the port here, what we do in the scenario that I just explained is like we put a connector into the port, and then we have a patch panel, and then we need a fiber patch cable from the port to the patch panel, and then we need the structured cabling between the patch panels. That would be in a scenario where you might have floor 1 and then floor 2. In the scenario where we had a switch 1 here and switch 2 here, we might want to do something where we use a direct attach cable, where we just connect the cable which has the connector included on it. So how the cable actually looks, I'm going to draw a terrible version of a twinax cable here, but this is what a twinax cable looks kind of like, where you've got the port here and then the port here, and this side of the twinax, this is the twinax or direct attach cable, and it's typically 10G or 100, can be 100 or 40 actually. It can be any of these speeds, but the difference is that this cable is directly attached to this transceiver and this transceiver, and there's distance limitations of 10 meters. They typically come in 1, 3, 5, 7 and 10 meter, but they've got the transceivers attached to the cable in the middle, rather than here where we've got 3 components from a cabling perspective. The structured cabling between the patch panels, the patch cable on the right, and then the patch cable on the left. That's enough about patch cables and transceivers, but hopefully it gives you a flavour of some of the things when we say, oh, we had a discussion with the team. Here's an example of the types of things that can take 1 or 2 hours and more research offline, and then another 1 or 2 hours, especially if we've got 100 switches with 2 uplinks and then a mix of speeds and a mix of single mode and multi-mode and all that kind of stuff that we talked about there. So we need to be very precise in the types of transceivers that we order for switches. There's another example of a thing that a network designer has to do. Okay, so to round off that whole SFP thing, I want to just show you some examples of the different types of SFPs that we just talked about. So an SFP, which we talked about in respect to like 1 gig, this is an example of that, where this is Netgear, so probably not what most people use, but the SFPs look pretty much the same, regardless of vendor. So here we've got a Juniper SFP. This is a copper SFP, which is effectively a 1 gig RJ45 1000 base T SFP copper connector. You can see that it's quite slimline there from the different pictures, quite small, and if you just search for it yourself you'll be able to see the dimensions, but if you think it's about the size of your middle finger, depending on the size of your middle finger, and if you want to use that as a reference point, but there you go. The same for an SFP Plus, where the main difference with SFP Plus is that It's typically fiber. There seems like there are some 10G base T SFP plus nowadays, so that's copper that can operate at 10 gig. But here, if we just look at like the fiber SFP plus with an LC connector, this is like a little plug that you pull that plug out, and then there's the transmit and receive pair for where you would plug your fiber cable into. The QSFP is slightly different. Let's just click on one of these. Here's a 40 gig QSFP, and you can see kind of the ballpark costs for these things, but they all kind of look the same, and but you can instantly tell the difference between an SFP or an SFP plus versus a QSFP or a QSFP 28, because they have these like blue pull lever things on them as well, typically. Okay. Then yeah, QSFP 28, you can see there that's more of the same. These are actually the twinax, which was the next thing that I wanted to show you. So you can see probably this one's quite a good representation, where we have a cable that is a copper cable, and it has the transceivers actually connected to the cable. So it's not separate cables, sorry, it's not separate transceivers at either end plugging into each switch and then attaching a cable. If you plug something into the switch at both ends, it's got the cable attached to the transceiver. So these are actually connected to the end of the cable. A couple of links here. We've got Cisco optics compatibility matrix. So I used to live in this document when I used to work for a Cisco Gold partner, and we wanted to check that certain SFPs were compatible with certain switches. Just taking a little minute to load there. It's probably due to the internet connection that I have at the moment. But then the Juniper has hardware compatibility with, if you go into a switch model, so this is a QFX 5100, which is a data center switch. It has the compatibility, so this is an SFP with 1 gig LX, which is probably single mode fiber, 1 gig SX, which is short reach typically. So that will be multi-mode, and then we've got copper 1 gig, then we've got long haul and all the rest of it. So we've got, and you can see as you skip down here, these are all the different types of 1 gig SFP. These are all the types of 10 gig SFP plus, and then we start getting into the 40 gig and also the 100 gig, and I'm sure 400 gig won't be too far behind these things. So the Cisco one, just while it's loaded, this is not what I really was looking for, but we do have compatibility information available to us. That's the user manual. Not looked at this for a little while, so let's just look here and see if the SFP, oh here's the SFP 10 gig SFP compatibility matrix. So yeah, you can see that there's a lot of different ways to find out, depending on the switch model and all that kind of thing. There's different optics available, there's different speeds and feeds, there's different optics types, single mode, multi-mode, copper, twinax, direct attach, DAC, all these are the same thing but different, and you really need to know what you're talking about when you're scoping out, especially data center switches or service provider core switches that you're looking to refresh for a customer. It's not always the switches that you're implementing either. Sometimes you have to take into account what the capabilities are of the switch at the other side. So if you put a switch in that has only 110 gig capability, but the other side has only got like 1 gig SFP ports, then you might need to think about like upgrading a module or something in the other end as part of your project. Anyway, that's enough on that for now. Hopefully it was interesting and informative. Cheers.